This is my SAR ADC sample and hold circuit. The pot is hooked up to the input of the LF398, and the multimeter is connected to the output of the LF398. When I turn the pot, you can see the value on the output is changing. This is because it's in the sample phase, but when I flip the switch, it's in hold phase. When I turn that potentiometer, the multimeter reading does not change according to the potentiometer. The capacitor is slowly discharging over time, and that's why it's changing. But the speed of the circuit, the entire SAR ADC circuit, makes the capacitor discharging over time not matter. This circuit needs positive 9, negative 9, and ground. To achieve this, two power supplies are put into series. On the vertical rails, you can see I have 9 volts. The two middle rails are both 0 volts, and the leftmost rail is negative 9 volts. The horizontal rails all have 5 volts because of the 5-volt regulator at the top left of the screen here. Now, it's not actually 5 volts, and the negative 9 isn't actually negative 9 volts. It's the voltage difference. If I put the yellow wire, which is the ground of the multimeter, into 0 volts, you can see I get 14 volts on the multimeter. That's because 14, right, minus 9 is 5 volts. The internals of the chip are actually pretty basic. On screen, I have a schematic of a sample and hold circuit I pulled from the internet. And as you can see, there's not much to it. You have C1, which is the hold capacitor, CH, on the LF398. And you have your input and your output, and a switch in the middle, which controls whether you are sampling or holding. So the analog signal will come in and it will charge the capacitor to whatever value you want, whatever analog value. And then once you flip the switch, it will disconnect the capacitor from the input, so the input can no longer affect the capacitor's voltage. The capacitor then goes through a voltage follower configuration. This will keep the voltage levels steady so it doesn't shift around too much. And then it's simply outputted.